Hello, welcome to Gate Academy. So we have seen how to perform operations on a continuous time signal and what are the effects of different operations simultaneously performed on any continuous time signal. For this, we have seen three different methods. That is, if you have to find any signal x1 of t, let you have given any signal x1 of t in terms of signal x of t, let it is given to you as minus k times x of minus alpha t plus t naught. So you can see here there are different operations that are first operation is plus t naught, that is shifting by t naught, then scaling by alpha, then reversal, then amplitude scaling and amplitude reversal. So for this you have seen that we can either apply operations from right to left individually, then we don't have to take anything common. First operation, that is preferable. Second operation, you can perform operations from right to left, but for this you will have to take common the coefficients of t. And the third operation was directly by replacement, that if you can define x of t mathematically, then by just replacing t by this variable minus alpha t plus t naught, you can directly find out the signal x1 of t. So now it's time to perform all of these operations on a discrete time signal. And if we are taking any example, let's say we have any signal x of n that is given to you graphically as, let it is your signal x of n with respect to n. Let the values are 2, 4, 4, then let it is 2, then minus 1, let it is 4 and 3. We are taking any arbitrary values. So it is point n equals to 0, minus 1, minus 2, minus 3, it is for 1, 2 and 3. So this signal x of n is existing only in the interval for n greater than or equals to minus 3 and n less than or equals to plus 3. So if you have to find out, let's say we have to find two different signals. First one, if we say x1 of n, that is related to x of n as, let's say x of 3 minus 2n. If you have to find the signal x1 of n, that is x of 3 minus 2n, and if we have to find out x2 of n, other signal which is related to x of n as x of n plus minus 1 to the power n x of minus n. Or we can take x of minus n and plus minus 1 to the power n x of n. If x of n, x2 of n can be considered to be sum of two signals. First you find this signal, then you define this signal values, then you have to find the sum of corresponding samples of x of n. So if you see, you have given that x of n is this signal. X of n is 2, 4, 4, 2, minus 1, 4 and 3. So if you see x2 of n, this is x of minus 1 part, then x of minus 1 will be, the values will be changing from positive half to negative half. Therefore, origin will be same at 2. Then after the origin, the values will be 4, 4 and 2. And before the origin, the values will be minus 1, 4 and 3. So it is your signal x of minus n. So you have obtained this part. Now what we have to calculate is minus 1 to the power n x of n. You know that if we are going to take any odd values of n, then this will give you the negative sign, and if n is positive, n is even, then you will be having positive sign. So if you expanded this signal minus 1 to the power n x of n, then what it is going to be? If we are taking this signal, let it is your signal x4 of n. Let it is your signal x3 of n. That is, if you are saying that x2 of n is equals to x3 of n plus x4 of n. If you have individually defined two parts, so we have obtained x3 of n, now we have to obtain x4 of n, that is minus 1 to the power n x of n. Then the values will be, if you want to have the value of x4 of n at origin, that is at n equals to 0, then put the value n equals to 0 in this expression, then the value will be 1 into x of 0. Similarly, at n equals to 1, the value will be what? 1 minus 1 into x of 1, then plus 1 into x of 2. Similarly, the values will be for n negative values also. So we have just tried to express this series that what will be the values contained in this minus 1 to the power x of n. It will be containing only the sample values of x of n, but now that values will be multiplied by either plus 1 or minus 1 depending on the number of n. If n is odd, then the sign will be negative. If n is even, then the sign will be positive. So if you see here, x of n is this signal. It can be said that it is x of 0, it is x of 1, it is x of 2 and it is x of 3. Similarly here it is x of minus 1, minus 2 and minus 3. It means value of n is minus 3 here, it is an odd number. So if you find out the value of minus 1 to the power n into x of n, then you just have to take multiplication of this value with plus or minus 1 decided by this factor. If it is odd, then we will multiplying this with negative sign. If it is even, then we will be multiplying with positive sign. So the values will be, first value if you see, for 3 it is odd number minus 3, therefore minus 2. Then the next value will be even, that is plus 1, into 4, that will be 4. Then again minus sign will come, minus 4. Then at origin we will be multiplying with 1, then this minus 1 will get plus 1, then minus 4 and plus 3. So it is your signal minus 1 to the power x of n having origin at 2. So if you have to sum these two signals, then you are going to find x2 of n, that is sum of these two signals. So at origin you just have to sum only the corresponding values of samples, that is for same values of n. So at n equals to 0, you will be adding 2 with this origin value, that is 2. So 2 plus 2, the value at origin will be 4. Value at n equals to 1, 4 plus 1, that will be 5. Then next value will be 4 minus 4, that is 0, and 2 plus 3, that is 5. Similarly, before this value, if you see here, it is minus 1 minus 4, that is minus 5. Previous value will be 4 plus 4, that is 8, and minus 2 plus 3, that is plus 1. So it is your signal x2 of n. Finally, you have calculated x of minus n plus minus 1 to the power n into x of n. So now if you want to perform such operations, if you just want to revise these operations, so we can take a simple example, that is a standard result for one of your upcoming topics. If you have said that x of k is represented as summation from, let us say n equals to 0 to n minus 1, x of n e to the power minus j k, or we can say j 2 pi k n upon n. Let it is given to you that x of k is being this given by this expression where k can vary from 0, 1, 2 up to, let us say n minus 1. Here we are varying the limits of n also from 0 to n minus 1, and we can vary values of k. It is also an integer which can be varied from 0 to n minus 1. So if it is given that for x of n, that is equals to 1, 2, 3, 4. We are just trying to find out the application of whatever we are studying with the same instance. So just to clarify your doubts, so just if we are saying that x of n is this value, and if n is equals to 4, then values of, or we can say that then the value of x of 0 plus x of 2 will be what? So what we have to find out? We have to find out the value of x of 0 plus x of 2, which is x of k at k equals to 0, this value, and this value is x of k for k equals to 2. So if you see here, if we are going to find first x of k at k equals to 0, that we are going to substitute value of k equals to 0 in this expression. So what will be the expression? Summation from n equals to 0 to n minus 1, that is 4 minus 1, 3. You are given that value of n is equals to 4. So now it is going to be x of n into, if you are going to take k equals to 0, it means now you will be having e to the power 0, and the value of e to the power 0 is 1. So there is no need to write anything for this expression, and you just have find out the value of x of k at k equals to 0. It will be summation of x of n simply from n equals to 0 to 3. So if you see here, it is, if it is not, origin is not mentioned, then you will be taking first sample at origin. So it is x of 0, it is x of 1, x of 2 and x of 3. So summation of x of n will be x of 0 plus x of 1 plus x of 2 plus x of 3. That we have substituted values of n from 0 to 3 in this expression. We have obtained this value, and if we sum 1 plus 2, 3 plus 3, 6 plus 4, that is 10. Now if we have to find out second, that is x of k at k equals to 2. If you find out the value at k equals to 2, then the value will be summation from n equals to 0 to 3 only x of n into e to the power minus j 2 pi, value of k you are going to put is 2, 2 pi k n upon n, that is 4. Now you can see here this 2 and 2 will get cancelled with this 4, and what you are obtaining from here is summation n equals to 0 to 3 x of n into e to the power minus j pi n. Now if n is integer, you know that e to the power jx, e to the power jx, or you can say plus minus jx is equals to cos x plus and minus j sin x. So if you see here, e to the power minus j pi n can be written as cos pi n plus j sin pi n. You know that any integer multiples of pi in sign is always going to be 0. So this part will be 0. So what it is? It is cos pi n, and cos n pi, you know that the value of cos n pi is what? Minus 1 to the power n. That is cos, you know that if you draw the plot of graph cos, then simply you know that cos is a function which is going to be either minus 1 or plus 1 at integer values of pi. If you see here, value of pi t is pi, if it is t, it is cos t. Then the values are plus 1 and minus 1, and where these peaks are occurring, these instants are pi, 2 pi, 3 pi and so on. So you know that cos pi will have, cos n pi will have either plus 1 or minus 1 values depending on the value of n. If n is odd, that is 1 pi, 3 pi, 5 pi, then the values will be minus 1. If n is positive, even, then the value will be plus 1. So it can be written that cos n pi is equals to minus 1 to the power n. If n is even, this value is positive. If n is odd, this value is negative. So now, if this factor can be replaced by minus 1 to the power n, then the similar expression you are going to get for this signal x of k at k equals to 2, that is equals to summation from n equals to 0 to 3 signal x of n into minus 1 to the power n, which can be written as minus 1 to the power n into x of n. If you are going to put values of n from 0 to 3, then the same thing will be happening as we have taken in this case, that is the values will be plus 1 into x of 0, minus of x of 1, plus of x of 2 and minus of x of 3. So the value, if you can see here, x of 0 is 1, minus 2, that is minus 1, plus 3, that is plus 2, and minus 4, that is minus 2. So the value that is obtained, that is to be obtained, is x of 0 plus x of 2, the value will be 10 minus 2, therefore x of 0 plus x of 2 is going to be 10 minus 2, that is equals to 8. Now that is the value, but if you see here, if it is going to be all positive values, and in this expression if there are some negative values, then these negative parts will be cancelled out if you are going to sum x of 0 plus x of 2, and what you are going to obtain is simply x of 0 and plus x of 2. So the values of, and this values will be get multiplied by 2 times, because it will be summed in x of 0 plus x of 0, that is 2x of 0, this value will get cancelled, plus 2x of 2, again this value will get cancelled. So you are getting value of x of 0 plus x of 2 equals to 2 times x of 0 plus x of 2. So what is the value of x of 0? X of 0 is 1, it is x of 0 and it is your x of 2. So 2 times x of 0 plus x of 2, that is 3 plus 1, 4 into 2, that is going to be 8. So it is the application, whenever you are going to find terms like this, summation 1 to the power n x of n, then you have to take values of x of n with alternatively positive and negative sign. Value of 1 to the power n x of n will be what? Plus minus with these values. Similarly, minus plus with these values multiplied, that will be giving you minus 1 to the power n x of n. So we have seen some of the operations, multiple operations on discrete time signals. We have seen operations on continuous time signal. If you want to solve simultaneously at this instant numbers of problems on operations on signals, then you can follow your lecture of workbook solutions in which your first 10 or 15 questions will be on practice on operations on signals. So you can practice the operations. Otherwise, it is I can recommend you that you just continue with this. This much practice is enough for you. Now we will be moving to our next chapter, that is elementary signals, and now we will be defining all of these operations effect wise on each of the elementary signals, and you will not be having any confusion. So now we will be taking elementary signals. So we have seen operations on signals that are possible to perform any continuous or discrete time signal. Now it is time to check elementary signals on which we are going to perform all of these operations. And in this topic, elementary signals, we will be taking continuous as well as its discrete part simultaneously. But to start with, we are going to start this topic with the signal with which almost all of you are comfortable, that is your step function in continuous time domain. So we are starting with continuous time step function or signal. So one more thing, if you say functions and signal, then you know that function and signal can be interchangeably used, but signal, where here what you have defined signal as, signal is what? It must be a single valued function of time. In signals, what you are defining, the signal, it must be a single valued function, means at any instant of time it must be only one defined value, not more than one defined value. So now we are going to take the topic that is continuous time step signal, and for your ease, let us say we define one more signal before step function, that is, let it is your signal x of t with respect to t, let it is changing its value from 0 to 1, let it is changing its value from 0 to 1 in a short span of time, and then it is going to be constant at 1. Let the short span of time that is needed to change from 0 to 1 value, let it is be t naught. So if it is a signal x of t which is changing its value from 0 to 1 in a very short span of time t naught, then it is being constant at 1. Then if you modify this signal and if you take limit t naught tends to 0, it means if we idealize this signal, that the time taken by the signal to change its value from 0 to 1, which was t naught, if we idealize this and if we take t naught tends to 0, it means the time taken for the change is momently, then the signal x of t with limit t naught tends to 0 is represent a signal that is known to be as your step function, that is step function, unit step function ut. If you plot this signal for limit t naught tends to 0, it means you are going to change the value from 0 to 1 in no time, that is at t equals to 0 only. So it will be the signal which can be represented, this signal can ideally be represented if this span of time that is going to take by this signal to change its value, if it is 0, then it will be changing its value from 0 to 1 at t equals to 0 only, and it is known to be your unit step function, that is ut, named as unit step signal. For this signal, if you see here, the value has started from t equals to 0 at 0. It means the value of signal was 0 at t equals to 0, and it has gained some value only after some finite amount of time. If that finite amount of time is idealized to be 0, then you are going to take the value to be 1 at t equals to 0 only, but you know that it cannot be possible that value is changed from 0 to 1 at 0 only instant. So if you are taking this, it means you are going to define some discontinuity at t equals to 0. You are going to define some discontinuity at t equals to 0, but for the basic definition, if you want to mathematically express the signal u of t which is changing its value from 0 to 1 at t equals to 0 only, then you define this signal u of t, it is being 0 for t less than 0. It is 0, this signal is 0 before t equals to 0, so it is 0 for t less than 0, and it is going to be 1 only for t greater than 0. We cannot take equality sign. Why we cannot take? Because we have seen that the signal was earlier 0 at t equals to 0. So if it is gaining its value, then some finite time is necessary. If we are idealizing that concept and we are going to take that finite time to be 0, then we can say that the signal is going to be 1, but not at t equals to 0, just after t equals to 0. So we can take value of u of t to be 1 for t greater than 0, and it is to be 0 for t less than 0. And it will be better if we write value for t greater than 0 first, because we have to choose the value that is non-zero. So we can write u of t is 1 for t greater than 0, and it is 0 for t less than 0. It means the signal u of t is having a discontinuity at the point at time t equals to 0. So it is discontinuous at time t equals to 0. And if you have to approximate the value at the point of discontinuity, then we will use Gibbs phenomena. So if it is some signal, let it is any signal which is having a discontinuity, you can see here, let it is your signal f of t with respect to t, let it is instant t is equals to t naught, where it is varying its value from, let us say it is a and it is b. So if you see here, the value of signal is constant before t is equals to t naught at minus a, let it is minus a, and the value is going to be constant at t is equals to at b for t greater than t naught. So if we have to define the value at the point of discontinuity, we can see here at t is equals to t naught, the value is instantly changing from minus a to plus b. So in such cases, value of signal f of t at t is equals to t naught, which can be written as f of t naught, is approximated using Gibbs phenomena, and you use the result, that is approximate value of f of t naught is equals to f of t0 minus plus f of t naught plus divided by 2. That is, if there is a finite discontinuity, that is the value is changing from one constant value to other constant value, then at the point of discontinuity you can define or approximate the value at t is equals to t naught by taking the averages of the value just before t naught and just after t naught, which is represented by f of t0 minus plus f of t0 plus divided by 2. It is known to be the Gibbs phenomena. It is not exactly the Gibbs phenomena, but whenever we will be taking that consideration, when we will be taking the chapters of filter, then we will be discussing this Gibbs phenomena in more detail. But for the time being, you can see that Gibbs phenomena can be used to approximate the value of a signal at the point of discontinuity by just taking the average values just before and just after the discontinuity. So it is used for, it is Gibbs phenomena. So f of t naught is equals to this. Similarly, if you have to define the value of this signal u of t at t equals to 0, then you can see that value before t is equals to 0, that is t0 minus is 0, and value after t equals to 0, that is t0 plus is again is equals to 1, and it is having a discontinuity at t equals to 0. So this u of t function can be more generalized to u of t is equals to 1 for t greater than 0, equals to 0 for t less than 0, and at t equals to 0, if you want to write the value at t equals to 0, then the value will be average, that is 0 plus this value, that is 1 divided by 2. So it will be 0 plus 1 divided by 2, that is equals to 0.5. So we can approximate the value of step function at the point of discontinuity by taking the average values, that is 0 plus 1 divided by 2. So we can write ut is 1 for t greater than 0, is 0 for t less than 0, and at 0 it will be 0.5 approximately. So if you see here, it is your step function. We haven't studied the impulse function, but if you still want to check the relation between step function and impulse function, then for the time being, just say I am just defining a function, let it is a function which is existing only at t equals to 0. Let it is a function, and I am not concerned about the value, I am not telling you the value, we just are confirmed that the value of this signal, let this signal is represented to be, let it is del of t, it is represented to be del of t. What we are saying that area is equals to 1. Let the area of this function x of t is equals to 1, which is existing at only at t equals to 0. The value, I am not saying that the value is infinite. For the time being, I am not saying that the value is infinite. I am just saying that value of this signal x of del of t, area of this signal del of t is equals to what? 1. So if we see here, what we have seen, that area of any signal, let it is your signal x of t. So we have seen that area of any signal x of t is equals to integration from minus infinity to infinity x of t dt, and for x of t you can write value of x of t signal, that is name of x of t, that is del of t dt. So the property, by the area property, integration from minus infinity to infinity, any signal is integrated from minus infinity to infinity gives the value of area for this signal. So if we are taking minus infinity to infinity integration of del of t dt, then it is equals to area of del t, and therefore it must be equals to what? It must be equals to 1. It means that we have seen that if there is a signal, we have seen that from the definition, area of x of t is what? We have just written, it is integration from minus infinity to infinity x of t dt or x of tau d tau, right? Now, if we have seen that if the signal is not existing for infinite duration, that is if the signal is having values only in between 2 and plus 5, let it is the values are constant at 10. So if it is your signal, then what you do is you take the limits only for the instance for which the signal is non-zero. So instead of taking limits from minus infinity to infinity, what you can take integration from 2 to 5 also, this signal x of t dt, and you will see that the result of this value and this value is going to be the same. That is, if it is 10 and 7, then the result is 70. So here also you will be getting the result 70. It means for generalized purpose, we have taken the sign limits to be minus infinity to plus infinity. So if you see this function, if this function is existing only at t equals to 0, then if you integrate this function either in limits minus infinity to plus infinity or in any limit in which this instant, that is t0 minus and t0 plus, this interval is included, then the value of area of this signal you will be obtaining, and the value of that integral will be 1 only. That is, if you are going to take integration from minus infinity to 0 plus del of t dt, then again it will be equals to area, and as this whole signal will be included in between these limits, therefore the area will again be equals to 1. Or you can say integration from 0 minus to infinity del of t dt is again equals to 1, or you can say 0 minus to 0 plus del of t dt, again it is going to be 1, as in all of these limits this whole signal is going to be involved. So if you see here, if you say that what you have written that u of t is equals to 1 if t is equals to 0, and u of t is equals to 0 if t is less than 0. You have written the definition of this unit step function. Now if you are saying, if you write any function, that is, let's say any function is x of t, that is given to be, or x1 of t you say, let it is a function which is given to be as integration from minus infinity to t del of tau d tau. It means what you are going to do, you are just going to integrate this impulse function within this limits minus infinity to t. Now what we have studied just now, that if this t value will be anything greater than 0, it will be either 0 plus, then again integration from minus infinity to 0 plus will include this function, impulse function, and the area will equals to be 1. So if this t value is anything positive, either it is 0 plus or 1 or 2 or infinity, in each of the cases if t is greater than 0, you are going to have the result of this integration to be 1. Therefore, we can say that x1 of t is nothing but u of t, as this integration is having value 1 only if this t is greater than 0. If this t is greater than 0, anything 0.1, then integration from minus infinity to plus 0.1 will include impulse function, and therefore area will equals to be 1. So it will be 1 only if t greater than 0, and if you take t less than 0, then integration from minus infinity to minus 2 or minus 1 will not include this impulse which is occurring at t equals to 0. Then for all t less than 0, you are going to have the value 0. So we have taken one relation, you can say that if we have defined step function, then if we haven't seen impulse function yet, still we can say that if there is any function which is existing only at t equals to 0 with area value equals to 1, so if area is 1, then that signal, if we take running integration of that function, that is integration from minus infinity to t del of tau d tau, then it will give us the step function that we have just defined ut, that is equals to 1 for t greater than 0, and the value of this function will be 0 for t less than 0. So we just have defined now the step function. Now we are going to take different operations on step function. So if we have said that this is your step function u of t, what you have drawn till yet, you have drawn u of t which is having value constant 1. Ideally it is for t greater than 0, but we show that it is having value 0 to infinity, value equals to 1. So it is your function u of t. Now if you are going to take amplitude scale this signal, so what will be the plot of, if you have to plot with respect to t only, if you have to plot 10 u of t, then what will be the value? You just are going to multiply the amplitude by the scaling factor 10. So earlier if it was having a value plus 1, so now 10 ut will be having value 10 into 1, that is equals to 10 for time t greater than 0. So it will be having value 10 for t greater than 0. Again, if you are going to plot for t, if you have to find out u of minus of u of t, it means what? Minus of u of t, minus of x of t, that means you are going to perform amplitude reversal. So if it is u of t having value plus 1 for 0 to infinity, then now u of minus t will be, minus of u of t will be having value minus 1 for the same instance from t is equals to 0 to infinity. Again, if you are going to take minus 10 ut, then this value minus 1 will be minus 10. If you are going to take this value as minus 10 ut, then you can write this value to be minus 10. So we have seen amplitude scaling and amplitude reversal. Now if you have to find out with respect to t, if you want to find u of t minus 3, then what you are going to do is, if you have the function x of t, that is u of t, and if you want to find u of t minus 3, it means you are going to delay that function, time shift that function towards right hand side by 3 units. So if it is u of t, and if you have taken this signal and you have shifted this from for a duration of 3 seconds, then if the signal is starting from 0, then that signal will be starting from t is equals to 3 seconds. That you have just delayed this function, you have slided this function 3 units towards right hand side. So this function will be existing from 3 to infinity for time t, and the value will be the value that is written just before the step function will indicate the magnitude, amplitude of that step function. So it is 1. Now if you want, then you can use the basic definition of step function also to find this value of u of t minus 3. What you have written is, you have written u of t is equals to 1 for t greater than 0 and 0 for t less than 0. So now if you want to find out u of t minus 3, so what you have did, that you have replaced t by t minus 3 in left hand side, so you must have to replace on right hand side also. So signal u of t minus 3 will be, this value is constant, so it will be 1 only. For now this value will be for t minus 3 greater than 0, or you can say that for t greater than 3 seconds. That is, value of u of t minus 3 will be 1, but only after t equals to 3. And as this value is 0 for, previously it was for t less than 0, now we are replacing t by t minus 3. So now it will be 0 for t minus 3 less than 0, or you can say that t less than 3. That means by these two values you can say that the discontinuity is now occurring at t is equals to plus 3, before which the signal is 0 and after which the signal is having value 1. So we can plot u of t minus 3 like this. This is the point of discontinuity where signal is discontinuous, changing its value from 0 to 1. After t is equals to 3, signal is constant at plus 1. Before t is equals to 0, signal is constant at 0. So if you see the basic shape of this step function, this step function is 0 from minus infinity to, it is constant at 0 from minus infinity to t is equals to 0. There is a discontinuity at t is equals to 0, and after t is equals to 0, signal is again to be constant at t equals to at value 1. So it is the shape, and if you have differentiated it, therefore you have obtained the function which is existing only at t is equals to 0, because if this function ut is constant for t greater than 0, then the differentiation of constant is going to be 0. Similarly, if the signal was 0 before t equals to 0, then its derivative will again be 0. Therefore, as we have defined that this ut can be considered to be running integration of del t, so you can also say that this del of t can be obtained by taking du of t by dt. That is, either we say that step function can be obtained by taking the running integration of impulse, or you can say that impulse function can be obtained by taking the first derivative of step function. If you will see that basic step function in ideal case, then this definition can bother you, but to simplify and to reduce this expression, we take the simplification, that is value of u of t is changing in a very short instant of time, that is t naught. actually it cannot be 0, ideally it cannot be 0, but practically if it is as short as it cannot produce any kind of difficulties in practical operation, then we can assume that this time which is required to change the value from 0 to 1 is negligible. So you take the value of t naught, the time duration to be 0. So this step function can be obtained by taking running integration of impulse function, and impulse function can be taken by the first order derivative of step function. So if you see here, again we are discussing that if you are going to differentiate this function, then for this reason signal is constant, so its derivative will be 0, and in this portion signal is 0, therefore its derivative will be 0. So we have find out the function which is existing only at t equals to 0, and if a signal is existing only at any finite instant, only at any particular instant, then it can have only the shape of a arrow that is represented as your function del of t. We will be discussing this function in more detail, but for the time being we were seeing the operations on a step function. First we have defined amplitude scaling, then we have defined amplitude reversal with amplitude scaling. Now we have seen that if you have to plot any function related to u of t, that is either it is u of t plus 3 or t minus 3, that is either delayed or advanced version, then either we can just shift that signal ut to find u of t minus 3, or we can use the basic definition that if u of t is 1 for t greater than 0, then u of t minus 3 will be 1 for this t minus 3 greater than 0, and we can find out the point of discontinuity, where this signal is going to change its value from 0 to 1. So we can use this method also. It will be the method which will be helping you to solve more problems with ease. Now if you see, we are having less space, so we will be seeing further. Hello, we were discussing unit step function in case of continuous time signal, and we have defined unit step function, that is you have said that it is a function u of t which is having value constant 1 after t equals to 0. So you have written u of t equals to 1 for t greater than 0, and it is 0 for t less than 0. In more general definition, you can use the approximation that u of t is equals to 1 for t greater than 0, it is 0 for t less than 0, and it is approximately 1 by 2 at t equals to 0. So if you want to find any operation on unit step function, like if you have to find out, if you have to plot for this signal ut which is starting from t equals to 0, let you have to plot u of t plus 2. So simply you have seen that it is with respect to t. Now we are going to take several operations. So we are starting with step function shifted from some constant value, that is if it is plus 2, shifting is, therefore we are going to advance this signal, and now this signal will be existing from minus 2 to infinity. It is existing from 0 to infinity, you just have shifted this towards left hand side. Now if you see here, it is having discontinuity at t equals to minus 2. So if you define any function, let it is any function given to you as f of t which is having values like this, like say this point is given to you as minus 2 and this point is given to you as minus 2 minus a. So if you say, or it can be minus 2 minus a to it point can be minus 2 plus a. So if you have to find, let the value is 1, so if you have to find limit t a tends to 0 f of t, if you have to find signal for limit a tends to 0, if this width, if you say here the width of this transition period when signal is changing from 0 to 1, if you see the width, then this width is going to be a, and if you have taken the limit a tends to 0, it means this transition period is existing only at t is equals to minus 2, because all these 2 points will be represented only as minus 2, therefore the signal will be like this, that is starting from t is equals to minus 2 and then it is constant at the value of a. So it is nothing but what u of t plus 2 that we have plotted earlier. So you can see that this function limit a tends to 0, either it is minus 2 minus a to minus 2 plus a, or it is simply minus 2. Both of these signals will going to give you the function that is u of t plus 2. So such kind of problems can come into your exam. We have seen that we can represent step function in terms of limits. If the transition period is going to be 0, then it represents a step function. So now what you have seen here, that if u of t is represented like that, then you have plotted a signal that is u of minus of u of t. then you have plotted it like this. It is your function. Now if you see the shape, then it is constant at 0, decreasing to -1, and then it is again constant at -1. This signal is your u of minus of u of t. Now if you have to find out, say for given u of t, you have to find out the time reversal of this function, that is u of minus t. Now for u of minus t, u of t you just have to take its time reversal. So if the function ut is existing from 0 to infinity, then after time reversal that will come from first quadrant to second quadrant, and this function that you will be getting will be having something shape like this. So now the shape is, it is having constant value at 1 from t equals to minus infinity to 0. It is discontinuous at t is equals to 0, decreasing from 1 to 0 at the same instant, and again it is going to be constant at 0. So this function is u of minus t. So it is u of minus t, it is minus of u of t, and actual u of t is like this. It is your function u of t. So if you just want to use the definition of u of t to find any other function that is obtained just by performing the relation, any operation on step function, then you can use the definition. Like if you have to find, say you have to apply time scaling. So if you want to find u of, with respect to t, if you want to plot u of alpha t, then to perform scaling, time scaling on any continuous time signal, what you do is you just divide the existing limits of that signal from scaling factor, that is alpha here. So if it is u of t which is existing from t is equals to one limit, that is for existence starts from 0 and it is existing till infinity. So if you divide 0 by alpha, then again you will be having 0, and if you divide infinity by alpha, again you will be having infinity only. Therefore the u of alpha t signal is same as that of u of t, which is having value 1 after t equals to 0. It is function u of alpha t. So from these two plots, or using by definition, if you say u of t is equals to 1 for t greater than 0 and 0 for t less than 0. So just by replacing this t by alpha t, what will be the value of u of alpha t? You just have to replace t by alpha t. So if alpha t is greater than 0, it means again t greater than 0, and if alpha t is less than 0, it means t less than 0. So the definition satisfies the definition of step function. So you can see that u of t and u of alpha t will be the same. So we have written that we can write u of alpha t is equals to u of t. Now we are going to seriously use the process of replacement. Now you can replace this t by any other function, that is if you want to replace this t by t plus or minus t naught. If you just don't want to take just t here, if you want to take t plus 4 or t minus 3, then what will be the value? So you can just replace on both the sides. So u of alpha times t plus or minus t naught, we have replaced t by t plus or minus t naught. So it will be equals to u of, if you have replaced this t by t plus and minus t naught, then by these two relation, what you can see is, if you see the relation and conclude, so what you can conclude is u of alpha t equals to ut. It means if there is a step function which is not shifted in its actual form, then scaling will not have any effect on step function. And if you have taken subscaling, some shifting, and then you are taking some scaling, then if you take scaling factor outside, then you can directly discard this scaling factor. See what is happening here. If you are having a function u of 2t plus 8. So what you are trying to say is, if you want, then you can take u of this 2 common, then the shifting will not be like in this case, the shifting will now be t plus 4, that is by 4 units. So what it is mean that if u of alpha times t plus or minus beta term is obtained, then it can be taken equal to, this scaling factor can directly be discarded and it will be equals to u of t plus 4 only, and this u of t plus 4 can easily be plotted. So whenever you will having any scaling, then you just take out that scaling factor, and according to that common, if you are taking something common, then according to that there will be modification in the time shifting factor that you have given in the actual question. But accordingly, if you have obtained this scaling factor common outside, then you can directly discard it, and this value will be equals to u of t plus or minus t naught. So if you see, we have to plot signal x1 of t, that is given to you as u of, let t by 8 plus 1 by 4. So if you want to perform operations from right to left, then how many operations will have to perform? first you will have to take shifting by 1 by 4, that is you have to shift the signal towards left hand side for advancement by 1 by 4, then you must have to apply time scaling by 1 by 8. Now if you see what we have studied here, if you can take this common outside, the scaling factor, that is if you take 1 by 8 common, then it will be t plus 2. Now if the common scaling factor is taken outside, then you can directly discard this factor and this signal is directly going to be u of t plus 2. So if you have to plot u of t plus 2, then you don't have to apply any operations and you just directly shift the unit step function towards left hand side by 2 units and that will be the answer. So this function is going to be like this, that is u of t plus 2, starting from t is equals to minus 2 having value 1. It is your function x1 of t. Now if you want to check, then if u of t is equals to 1 for t greater than 0 and 0 for t less than 0, then just by replacing this t by this variable, that is if you want to find u of t by 8 and plus 1 by 4, then it will be equals to 1 only if this t by 8 plus 1 by 4 now is greater than 0, or you can say that t by 8 must be greater than minus 1 by 4 or t must be greater than minus 2. So what you have obtaining here, t must be greater than minus 2, then only the value of the signal is going to be 1, otherwise it is going to be 0, that is if you substitute t by 8 plus 1 by 4 less than 0, then you are going to get t less than minus 2. So you can find out that the discontinuity is now going to be at t is equals to minus 2 at we have plotted here. The discontinuity will be at minus 2 before this value, the signal will have 0 value, after this signal will be constant at 1. So it is the time scaling and time shifting, if you combine, then you can take outside the time scaling factor and you can then apply the time shifting according to that scaling factor. So if you see, if you have to plot say x of t, that is u of, if you combine one more operation, that is u of minus 4t plus 5. So if you see here, what result we have obtained is, we have written first that u of kt is going to be same as u of t. Then what we did, we have replaced this t function by t plus or minus t naught. So we have written then this value will be equals to u of t plus and minus t naught. We have replaced on both sides t by t plus or minus t naught. Now if we want to replace this value, if we want to replace this k by minus k, or you can say like from this directly, if you replace t by minus t, then what will be the value? U of minus kt. If you are replacing t in this relation by minus t, then u of minus kt will be u of, you will have to replace this t also by minus t. It means u of minus kt is going to be u of minus t. Now if you substitute in this relation, if we replace t by t plus or minus t naught on both sides, then what you are going to get, u of minus k into, we are going to just replace this t by t plus or minus t naught. So it will be equals to u of this minus sign, and thus for this t we will have to take t plus or minus t naught, that we have replaced on left hand side. So you can see here that this u of minus k into t plus or minus t naught, again this scaling factor you can discard and this value will be, this minus sign will be there, that is minus of u of t plus or minus t naught. So using this concept, it is again important, we will be summarizing results of these operations, but for the time being we just have obtained two relations, that u of alpha t is ut, and if scaling and shifting are associated, then scaling can be discarded after taking that scaling factor common. And now we have seen that if there is time reversal also, then also you can take negative sign outside and with scaling factor, and this scaling factor can be removed. Like if we apply this concept in this problem, then x of t is going to be, if you take this minus 4 common, so you will be having this minus 4, if you take common, then it will be t minus 5 by 4, that is 1.25, right. So now we will have to keep this negative sign, but we can discard this scaling factor, that is 4, so it can be discarded, and the value that we will be obtaining is u of minus t and minus plus 1.25. So it is now going to be simply u of minus t plus 1.25. So now if we have to plot this signal, that is we are not going to plot this same signal, we are just now going to discuss if the operations that are combined on step function is if time reversal and time shifting. We have seen effect of combination of time scaling and time shifting. Now if you want to see the combined effect of time reversal and time shifting, then we are going to discuss this, that if it is your function u of t, if you have plotted signal u of t here, and now if you have to draw two signals, that is by performing time reversal and time shifting on step function ut, if you have to perform these two operations. So first you have to plot, we have to plot here first u of minus t plus 4, and then we want to plot u of minus t minus 4, if we have to plot these two signals with respect to t. So you just plot it, pause the video and just plot the signals. You can definitely plot these videos and these signals. So if we have tried and you have plotted the signals, so what we have to do is, if we apply the operations from right to left. So first, in this case, we first shift u of t signal by 4 units. That is, if it is u of t plus 4, then u of t, then your signal u of t plus 4 is going to be started from t is equals to minus 4. You have shifted that signal left side by 4 units. It is your signal u of t plus 4 if you apply the first operation, that is time shifting. Now if you have to take time reversal, then you will have to take time reversal on this function, and after time reversal, if before it is existing from minus 4 to plus infinity, then after time reversal it will be existing from minus infinity to plus 4. So finally you will be getting this signal as starting from minus infinity and terminating at plus 4, value will be 1. So it is your signal u of minus t plus 4. Now if you want to find this signal u of minus t minus 4, so if you perform time shifting by minus 4 now, so it is u of t. If you plot u of t minus 4, so now the signal is going to be started from t is equals to plus 4. With respect to t having value 1, this signal is your function u of t minus 4. So you first have applied time shifting on step function. Now you have to take time reversal on this resultant function, and if you take time reversal, this function is existing from plus 4 to plus infinity. So after time reversal, this function will be existing from minus infinity to minus 4. So now if you plot this function, then it is going to be existing in between minus infinity and minus 4, value 1. So it is your signal. So now you can conclude that if there is negative sign with t in step function, either in this case minus t plus 4 or in this case minus t minus 4. If there is negative sign in t, that is if you are going to take time reversal on step function, then definitely the function that will be obtaining will be starting from minus infinity. In both the cases, what we can see is both the functions are existing from minus infinity. So both the functions will be starting from minus infinity if there is negative sign in t, and then it will exist up to the constant which is written here. Like in this case, if it is plus 4, then after starting from minus infinity, the signal will be terminating at t is equals to plus 4, as in this case. And in this case also, if it is minus sign, then it will be starting from minus infinity and it will be terminating after retain the constant after this t. In this case, the constant is minus 4, therefore it is terminating at minus t. So in common case, you can write that u of minus t plus t naught. In two cases, if t naught is less than 0, that is if t naught is negative, like in this case, and if t naught is greater than 0, like in this case where the shifting is greater than 0, that is if you are taking advancement. So now if you see here, in this case signal will be in both the cases will be starting, it will be starting from minus infinity, starting from minus infinity. In both the cases, either t naught is negative or t naught is positive, the function will be starting from minus infinity, but in this case the function will be terminating, that is will exist up to, in both the cases, if t naught is negative, then it will exist up to for t less than 0 only. Means if it is t naught is negative, then the function will be terminating in the negative half only. So it will be existing only for t less than 0. It cannot cross this 0 boundary because t naught is negative, so it will be terminating before this origin. By this line, I just want to mention that this signal will be existing only in the left half of the S-plane. It can be exist up to this point if it is negative, but if it is negative, then the plot cannot cross the 0 point and it cannot be exist up to any positive value. Similarly, if t naught is greater than 0, then still it will be starting from minus infinity, but now it will be terminating at t naught, which is a positive value. So it will be, in both the cases you can say it will exist for t greater than 0 also, but in both the cases the plot will be terminating, in both the cases plot will be terminating at t naught. This t naught may be positive, may be negative, but the plot of this function u of minus t plus t naught will be terminating at t naught. So if in this case if we are having this value, that finally we have obtained that this signal x of t can be simplified to u of minus t plus 1.25. So due to this negative sign, you can say that the function is going to be started from minus infinity, and this is the constant plus 1.25. Therefore you can directly plot this signal now. It will be existing from minus infinity to this positive value, that is plus 1.25 with respect to t having value 1. It is your function x of t, that is u of minus t plus 1.25. So if it would be negative minus 1.25, then this plot will be terminating at t is equals to minus 1.25. So we have seen scaling, then shifting, then we have seen scaling and reversal, and now reversal and shifting is now understood. Now you have to apply these properties, these operations on various other signals also, and this step function, we are going to now see the implementation of step function, what is the utilization of this step function, and now we are going to just introduce the word causal and non-causal function.